Hello everyone. Please confirm to me if you can hear me well, if my voice is clear, and if everything is clear. And welcome to today's session. So today we will continue on the Spring Data GPA. So today we will see so many things, things that will help us improve the performance, improve the application, writing a better code, a better performing code, and so on and so forth. So I'm just waiting for you in the comments just to mention if everything is fine and if you hear me well, and we will wait just few minutes until everyone joins, and then we will start today's session. So just let me know in the comments if you hear me well, and then we can start. All right, so welcome back again. Okay, so I think everything is fine and you can hear me well. So I guess we can start. All right, so today we will see so many interesting stuff, starting with something that I think and I see that it's really important, and this is something that you need to have in your code when you code your application, because it helps improving the performance of your application. So let's start with drawing something. So here, imagine that you have your table. So here we have a table and we have a list of rows. So let's see, or let's assume that we have 100k rows in this table. All right. So usually when we implement code, we always have a method find all and find all by. All right, so and also we have find all by. So this will fetch, or this will try to get the list of the elements of the rows that we have in the table. So we will fetch it from here, but if we do not include filters, this will return the full content of the table. Even if we add this by right here and we do some filtering, we might result in really large data. So here, let's assume that our table contains 100k rows or 100k records, and within this filter by we get, for example, let's say 10k. So we just filter and we get 10k elements. Let's say, for example, fetching comments or fetching data, any kind of data. So the issue in here is that returning all these elements to the front end, or to the client, generally speaking, is too much. So this is really too much, because serializing all this data, sending it over the network is really too much. So here, what we need to do? So here we need to include, or we need to introduce something which is paging. All right. So we need to page. We need to have pages of these records or of these results. So the page, let's assume, for example, because before moving to the implementation, or to this part, why we need paging? So you might say, okay, I can do paging on the front end. All right, so I just send all this data, these 10k records, and I do the paging on the front end. So will this will result in the same thing, because we will have so many data to serialize and to send over the network. So the request itself, it might take a few seconds, or our response should be really almost immediate. All right, so if we have a request that, or if the user needs to wait 10 seconds or needs to wait 1 or 2 minutes to get the data, this is too long. All right, so one of the solutions, or one of the best solutions, is to use paging. All right, so we need to page our results. So paging means what? So we need to define, or we need to get the page, the page number, and we need to get the size. All right, so here it depends on what we want to display on the front end. So for example, let's say the front end wants to display different elements, or different page sizes. Let's say, for example, default is 5, and then we have 10, and then we have 20, 30, blah blah blah, until 100, for example. So here we need to have a page. So this is just a number, and the size needs to be among this one. So this is up to the front end to decide. We can also have a default value. So I want by default to send or to receive 5 elements per page, and the page is by default 0. So 0 means the page 1. So it's 0 indexed. So this is the page number 1. So here, what I need to do, all I need to do, for example, among these 10k elements, I need to get which page I want. So here, we will have 10k divided by 100, for example, or 50 or 30, or whatever the page size, and this will give us the number of pages. All right, so the number of pages in here. So here, what I need to do, all I need to do is just to send the parameter, or to say, okay, I want the page number X with the size Y. All right, and this will give us, and this will improve the performance of our application, and this will give us more flexibility to return or like to fetch the data in a correct way. So now let's move on and see how this works within Spring Data JPA. So I will go, for example, to category or to game, since we have our game service in here, just a class to use it, because later on we will do a cleanup before moving to the real implementation of our application. So here, just to remind you, we have our game service and our game repository. Just a quick reminder, JPA repository, it already extends a list paging and sorting repository. So like we already have something that that accepts a pageable, right? Or that accepts a page parameter, which is this one. All right. So this is already ready for us, so we can directly use it. All right, so now how to use that? So by default, so here I will just do a public, I'll just make it a void. So paged result, and then I will pass the parameters later on. So here when we call our game repository dot find all. So among this find all, we have like few methods. So we have just find all. This will retrieve all the elements in the table. We have a find all where we can pass a sorting, like when we can pass a sorting parameter, and this one is the one that interests us in this moment, which is like passing a pageable. All right, and the rest is like an example, so which is like the query executor or like query by example executor, and this is the one we will see just next, which is this one, query by example executor. So now just coming back to this. So the find all, we have a find all method where we can pass a pageable. So now how we can create a pageable object. So here I will do create a pageable, and then a pageable, like a page request dot off. So all I need to do is to pass the number and the size. All right. So I guess I imported the wrong one. Yes. Yeah. So all I need to pass, or like just page request dot off, and then all I need to pass the page number and the size. So here all I need to do is to pass this pageable parameter to the find all. All right, so like this is a built-in method. So what if I want to have my own paged method? So here, for example, we have a list find all by category name, or like any find all method. So all I need to do, just in this case, for example, I will just duplicate this method. All right, so here I want to find all by category name. So I want to pass the category name, but I know that this list might be too long. All right, so like for one category we can have like thousands and so many games. So here all I need to do is to pass a pageable object. All right, so always like be careful when you import the pageable interface or like the pageable object. It should be from the correct package, which is org.springframework.data.domain, not the Java AWT print. All right, so now I have my method that will return a paged result. So now coming back to here, so for example, here if I use by category name, and here let's say for example, I'll just pass any string, so like any category, and I want to get or like to fetch my result as a pageable one. So here this is a static parameters. So here all I need to do is to have a final int page number and the final int size, and here all I need to do is the page and size, and that's it. All right, so now what is the return type of this find all by category name? So this by default, like for us, we created it as a list, but if we use the find all, so I will just do it in here, game repository dot find all, and I pass my pageable object. So let's see here what is the return type of this one. It will return a page of game. So here let's check this one. So like it's a page, it will return an object of type page, and this class or like this interface is a typed one, is a generic one. So here let's see the object page. So this object page, it's an interface, and it has so many like few methods and few parameters, like get total pages, total elements, like mapping, and so forth. All right. So here we can also see one of the implementation. Like for example, we can check this one, like this page ample, or like this page implementation, and here we see that we have a total. We have like a bunch of methods like get total pages, total elements, if it has next, if this is the last page or not. This is like a mapping method, toString equals and hash code. All right. So, and also like it extends a chunk. So like a chunk means that a bundle or like a sublist of our result. So here all I need to do is to store my result. So like for this one we need to change. So like it's not a list of games, but it should be a page of game. All right. So here I have, or like this will return my page of game, right? So like this is the second method. So here I will create a page object. So like I will have a page of game, and I will call it paged result equals my result. And then all, like I can access, for example, from my paged result, and I can access, for example, get content. I have like all the methods that I already shown. We can also like do a mapping. We have a total elements. We have also like other methods, like for example, has next, or like is last, is first, and so forth. So like all these methods are available for us. So also the point in here, if you see that the results, or like the data that you have in this page is too much, you can just create your own paging content, or like a page result class, and all you need to do is to map this result into this one. So this is what I mean in here. So for example, inside this common package, I will create this one. Maybe we might use it later. So I will call it page response, and this one, it will be a generic one. So like it will be like of type T, and here I will have a private list of T, like of this type. So like for example in here, if I create a page response of type game, we know that this list will be of type, or like a list of type game, and I will call this one content instead of data. I can also have a private int total elements. I can also have a private int total pages. So like from the total elements, I can know how many elements do I have in my database. The total pages, how many pages do I have? For example, we can have not the size, but a boolean is last, for example. And I can have another boolean if this is the first, or like a has next, and so forth. So like we can define many attributes as we need in here. So here I will just add my getter and setter, and all args constructor, no args constructor, and my builder method in here. All right. So now I have my page response element. So now how can I map this? So like it's quite easy. So for example, here, imagine that I want to return a page response of type game when I want to call this paged result. So here all I need to do is to return a page response dot builder dot build, and now all I need to do is to construct these elements right here. So for example, the first thing, the content is the paged result dot get content. All right. And then I have a total elements, or a total pages. Also, I can set the total elements, which is my paged result dot get number of elements. And for example, I have the is last, or like the is first. Maybe I can call them is last and is first. This will be much better. So here is last. Okay, so is first, and then is last, and I think that's it. All right, so now all I need to do is just to return this object. Okay, so here this is not a mandatory thing. So if the page result, or like if the page object is fine for you, or like it contains all the information, or like you assume that it does not contain more information or like extra information that you do not want, what you can do, you can just return this page of game. All right, you can just return this page object. But for my case, I see that I have too many information in here, and just creating a page response, which is a generic one, this is much easier for me. So like I can get the content, total pages, total elements is first and is last. And if I need, for example, extra things or like extra information, I can just add it and then return this element right here. All right. So this is about paging. Also, like when we have a page request.off, so this page request.off, it has also like two other methods, or like two other parameters that we can pass. So here we have always like page number and page size, and also we can define whether the sorting. So like we can have a sorting, for example. So here we can do, for example, sort.by, and they can specify the direction, and for example, sorting by ID, or maybe created at, or something like that. So for example, for the game, let's say I want to sort them by title. So all I need to do is to pass the property in here. And here, as you can see, so like this is very important. So maybe let me break the lines in here so you can see everything. So here also in this way. All right. So now we have the page, we have the size and this sorting. So here you see that this sorting, or like this sort.by, it's a list of string. So this notation in here, like the type, and then we have like the type and then 3 dots. This means that we can pass one or more, or like 0 or more elements, like 0 or n elements of type string. So here, for example, if I just remove this one, so this will work. All right. So like if you have, for example, if you want to pass to create a method, like if you want to create a method that accepts optional arguments, like one or more, so you can use this notation right here, like it's called like the var args. All right, so here, for example, I want to sort by the title, and then let's say, for example, I don't know, maybe supported platforms or any other thing. So here what I can do, just a comma, and then I pass the second parameter. So here, I don't know, like create time, just an example. So for now, we do not really care about the attributes, because it's just a theoretic part where we want to understand and see the power of Spring Data JPA. So here we have like our pageable object. So like if I want to do a sorting, I don't need to create, for example, here find by find all by category name and sort by title and create time and so on and so forth, or like even defining it in the query, in the named query. So also I can use this element, or like this sorting object, when I have a paging or like a pageable result. All right, so like this will sort the list, and then this will sort the full result, and then we will be able to get the page of size of like the page number and the size. All right. So also there is something I wanted to mention the last session, but I kind of forgot. So here, let's imagine that I want my games to be always sorted by something. All right. So there is an annotation. It's called order by, and then I can specify here like the order number, all right, or like the order filter. Let's say, for example, title in here, and I guess I'm missing something. Value. Value equals title. So here, okay. All right. So let's just forget about this one for now, because I think the other method is now deprecated. but I can also show it to you in here. So here we have, for example, we have the comments, we have the game, and for the game we have a list of comments. So here, let's assume that I always want my list of comments to be ordered. I can use here the order by, and then I can pass the value. And here, for example, for the comment, we have a content. For example, like I want to order it by content. So here, all I need to do is to do that. And here, for example, when I get the list of the game, when I get the game or like a list of games, and then from the game, I want to get the list of comments. And imagine that I want my list of comments to be always sorted. Instead of writing or like typing my own query to sort the comments, or like getting the list of comments and sorting them using Java code, I can use this annotation, which will make my life so much easier. So here I just need to add an order by, and the value is a content. All right, and here, as you can see, like the default is empty, and we can have like multiple order by annotations. All right, so here as you can see, we have an order by zip code.zip, zip code.+4, and this is like one example. And we can have, or like we can pass many parameters to order with. So for example, I can have I can pass another one. So now we just can get rid of the value and ID, for example, and content, and so forth. All right, so like this was something that I wanted to mention before moving on. So now we saw the paging. So like, put in mind and always remember that paging is something important. All right, so like this will improve your application performance, because you will not fetch all the data from the database, and you will not return all the data at once to the client. So this will help a lot improve your application performance. So this is one thing. So now we will move to the next part of what we want to see today. So today we want to see something also like it's really interesting. So I can close this one. I only need the game service and the game repository. So I will keep this code in here just for you as a reference, and then we'll clean it up later on, as I mentioned. So in the game repository, the JPA repository, it extends also an interface called QueryByExample executor. And this QueryByExample executor, so like maybe like it's an interface to allow execution of QueryByExample, and this is the example interface. So we have like many of methods. So like it will be an example.off, so where we can pass our filtering objects. So the idea behind this QueryByExample executor. So this means that, for example, I have my entity in here, or like I have my table. So I have my table in here, and I have few columns, or like I have a list of columns. All right, so like I have a list of columns. So for us, we like, when it comes to the Java code, we work with Java classes, or like Java objects. All right, so we work with Java objects. So here, when we want to filter, for example, let's say that this is field 1, field 2, field 3, and then field n, for example, like, and field 2 is the name of the field itself, or like is the name of the column in my database, or like in my table. So now I want, for example, to search for an object, or like to filter for an object. And okay, let's assume that I'm not that perfect, or like I'm not that good with SQL queries. So one way of making my life easier is to use the QueryByExample executor. So the QueryByExample executor, it will help us to write a query, or like to filter data. But we have some limitations. I will mention them once we are done with the example. I will mention the limitation that we have within the QueryByExample executor. So now let's see how I can do a QueryByExample executor. All right, so here I will have another method. It will be a public void QueryByExample. So what I want to do in here. So for example, I want to fetch, or like to find a game by game. So like I want to filter, or like I want to find a specific game by title, for example. and assuming that the titles, or like this should be the case, by the way, the title is unique in my database. All right. So now what we have, so for example, I have my game repository. All right. So like the auto completion, and I have, for example, I have a find one, and this find one method, it takes an example and it returns an optional of type S, like the S is the game itself, or like is the entity itself. So here I want to have, or like I want to pass to find a game. So here, let's say an optional of type game, let's say my game equals game repository dot find one. So now, assuming that I want to find a game, or like I want to search for a game by its name, all right, or like by the title, all I need to do is to do the following. Here I need to create an example of type game. All right, so let me import this one, and here let's call it example equals example.of. So here I have a game dot, or like I just, all I need to do is to pass my game object. So here I will create a game in here. So game equals new game. So now I want to do game.set title, and let's say, for example, The Witcher 3. So like this is one of the games that I know. So I want, for example, to search for the Witcher 3. All right. So like we have, I guess we have other parameters. So we have supported platforms. Let's say, for example, I want it for PlayStation, just an example. All right, so now all I need to do is to create an example of game. All right, and here all I need to do is to pass the example as a parameter. All right, and now this will return, or like this will filter the game based on this, based on what I passed as a parameter to this example object. All right, so like example.of game, so it will try to find, and here like this first example is a case sensitive matching, right? Like you need to be careful in here. So like this is like a case sensitive matching. So in case, for example, in my database, in my DB, I have The Witcher like this, or like, yeah, The Witcher 3, for example. This will return nothing. All right, so like this query in here, it will not return anything because what I have in here is a case sensitive. All right, so here I will add case sensitive just to make sure, just to make it clear that this one is a case sensitive. So now what if I want to make this one case insensitive? All right, so like whatever I pass in here, all I need is to have the same thing, or like all I need to have is to have the same string, no matter what the case is. All right, so I will just duplicate this method, and here I will say just insensitive. All right, so now I have my object game, and I will set the title in here, and now I need something else to make the query executor be case insensitive. All right, I need to add a matcher. All right, so like this will remain the same, and here I will add an example matcher. All right, so I have an example matcher. So by default, this is the one. All right, by default, it's an example matcher.matching, and the way we pass it is a matcher like this. So like when what we see in here is exactly the same as this one, but what we want to do, we want to change this one. All right, so we want to make it say case insensitive. All right, so here I want to do an example matcher dot matching all. I want to match everything with ignore case. All right, so like with ignore case, this is what I want. So this will ignore the case, and now when I pass the object, the example in here with this matcher, so this will try to find the game where the title is The Witcher, or like where the title equals The Witcher 3, but this will ignore the case. So like it's exactly what we did in here the last time. So let me just try to find it. Yeah, so like something like that, like this, like using the upper or the lower. All right, but this we can do it via the code, or like using the query example, like the query by example executor. Sorry for that. So now what if we want to have a custom matching? All right, so like for example, I want to have a custom matching. So for example, I want to have my title, the title to be, I want it to be like case sensitive, and for example, supported platforms to be case insensitive, or the other way around. All right. All right. Also, let's say, for example, I want just to pass something like this. All right, maybe duplicating the method is better. Query by example. Let's call it custom matching. So we'll have always our object game, and now I want to find all the games that the title contains Witcher. All right, I want to find all the games, or like one game, like it should be the same, that when where the title contains Witcher, and we will change this one this one we will change it to return a list of games. All right, so now the first thing that we need to do is to adjust our example matcher. So I want this title to contain and ignore case, and this one I want it, for example, to be matching, or like even we can say like ignoring case or something like that. All right, so now the first thing we need to do is here I want to do a matching any, since I want to fetch everything. And here I can add a method. It's called with matcher. So like with matcher, it takes two parameters, mainly like the property path, or like the attribute I want to filter with. So in this case, it's the title. And then we have the second property is the matcher, or like the generic property matcher. So here we have an example matcher. So like this is the auto completion from IntelliJ, but I will just remove the unnecessary parts. So here we have, I want it like with a matcher. So for the title, I want to use the generic property matchers, and instead of exact, I want to do contains. All right, because here I want to filter, or like to find all the games where the title contains Witcher. All right, and also I want it to be I want to ignore case. I can add ignore case in here. So like this will ignore the case. So for example, I want to add another one. So in the same way with matcher, supported platforms, and here let's say for example exact instead of contains and ignoring case, or we can do the other way around. So like you can play with the examples later on. So this will what this will do in the background, or like in the backstage. So this will create a query, select star, or like select all from game, where title like %Witcher %, and ignoring case. So like imagine that we can use the lower function, the same as we used in here, like we have upper and we can use the lower, and then and like the rest. So maybe let's write it in here. So like this is the query, the output query. So this might be much easier for you. So it will be select star from game, where, or like maybe let me break the line. So this will be select star from game, where title like, and here %Witcher %, because this is the first part that we have in here. I want the title to contain ignore case. All right, so here what I can do is lower, like using the lower method on the title. So like lower method, so like I just transform the title to lowercase, and then like Witcher %Witcher, %Witcher %, and then and supported platforms equals, not like, because like this means contains, but here I want to have an exact match. All right, equals PS, for example. all right, or like PlayStation or Xbox or any other supported platform. So this is the output query after using this query example matcher. And now instead of using find one, we have also like a find all using the example. All right, and here it will be a list of games. All right, so now this is how we can use a query execution, or like the query by example executor. There is also one thing one more thing that I want to see within this one, and then we can move shortly for a Q&A session, and then we will continue with the GPA specification. So now I will create, for example, another public void query by example ignoring. So ignoring properties. So I will explain what this ignoring properties is. I will just copy this one because I just need it again. And in here, what I want to do. In here, I want to filter. So here I will just keep the Witcher, or like the, sorry, not the Witcher, but the title. So now I want to, for my query, just to filter everything, but I want to ignore some fields. So like I just want to focus on the title somehow. So this is what it means. All right. So again, I will use an example matcher. So it will be an example matcher dot matching any, and here with matcher. So let's say, for example, the title containing, or like starts with, for example, instead of contains, here we have a bunch of methods. I think it's worth checking. We have exact. So this means that I want an exact match, like, so like this, the input string should be the same as the title. Contains is like this one, like percent, and then the value percent. Ignore case sensitive. Ends with. So ends with means something like this. So like the text and then percent. So like, sorry, it's the other way around. So this is what means ends with. So like the title should end with Witcher. And we have also starts with. So like we have starts with. So this means that it should be this one, or like this way, like the value and then percent. So this means starts with. And we have also like another option. Let me check it again, which is a regex. So I can, for example, pass a regex pattern to select the data, or like to filter my data. All right. So now let's say, for example, this one I wanted to be starts with ignoring case, and then, for example, I want to ignore the supported platform. So like do not filter, or like do not care about the supported platforms. And here I can do with ignore paths. So here all I need to do is to pass the list of the paths that I want to ignore. So here, so for example, in the game we have a title, we have a cover picture, category, comments, and so on. Well, not the category and comments, but we have the title, supported platforms, and cover picture. And here I want to ignore supported platforms and cover picture, for example. So this will ignore all these attributes. All right. So now let's create our example, and now all I need to do is to run my find all method. So this will ignore all these fields that I have in here. All right. So now before moving on, let's talk about the limitations of using query by example executor. All right. So one of the limitations, which I see it's really important to know, is like nesting and grouping statements are not supported. So for example, having first name, or like having title equals something, and other thing equals something, or, so like this mean, like I mean by this. All right, let me explain it in here. So here, let's say limitations, or like query by example executor limitations. All right, so the first thing, as I mentioned, is like nesting and grouping statements are not supported. So this means what? This means that if I want, for example, if I want, so like this is not supported, like what I will put in here is not supported. So if I want to do select star from game, where title equals let's say just the first, like the first parameter, and sorry, and supported platforms equals a second parameter, sorry, another, like a second value, or like a second parameter. So this one, so like in SQL I can do the following, or yeah, or like maybe let me break the line, or I want to have, for example, cover picture is not null. So this is not supported, like nesting, or like grouping and nesting statements. So like this is grouping and this is nesting. Nesting also, like for example, having something or ID in, or like title in, so and so forth. So this is not supported. Maybe if I put this in one line, this might be like much readable. So this type of queries is not supported by the QueryByExample executor. All right, so like the second thing, or like the second limitation, is string matching only includes exact, case sensitive, starts, like the methods that we saw already. All right, starts, contains, starts, ends, contains, let me fix this typo, and rejects. So like we do not have more operations on strings. All right, so like this is the ones, or like the methods that we just saw in here. So this is also like one of the limitations. We do not have a variety of methods that, or like of string matching that we can use. So also the final one, all types other than string are exact match. All right, are exact match only. So like if we have any other type other than string, it will be always an exact match. So like we cannot have a case sensitive, case insensitive, and so forth. All right, so these are the limitations of the QueryByExample executor, but it's still something really usable, something really really helps to improve, or like to write some good code to like to fetch the data, or like to filter the data. So like instead of writing maybe long queries, doing a lot of stuff, we can just use the QueryByExample, like an example and the QueryByExample executor, and we can do the rest, or like we can filter the data. Always think about using an example matcher if you want, for example, to have like if you want to ignore the case, or like not to ignore the case, if you want like to filter like based on contains, ends with, starts with, rejects, and so on and so forth. So like always try to think, or like always try to have your queries, or like your code looks like this, like an example matcher, and then an example where we pass the matcher and the game, or like the object that we want to filter as a parameter. But if you want always to have something, or like an exact matching, you don't need the matcher in here. All you need to do is to create your object and create an example of that object, and this will be an exact matching. All right, so now we'll pass to the Q&A session. Maybe like we can use it as a small break in order to digest all this. If you do not have questions, just write me in the comments so I can directly move to the next part. But let's see if you have questions that I can answer. So now I will just type this, commit this one. Spring Data GPA, and here query by paging and sorting. And then we have QueryByExample executor. All right, let's commit and push this one. And now I will move on and receive your questions. So go ahead, write me in the chat if you have questions. If you do not have questions, please write me that you do not have questions, so we can move to the next part. All right, I see that you do not have questions, so we can go back and move to the next part. So actually we have two things that we want to see next. The first one is mainly we want to see the specifications and the projections. These two topics are really important, and it's a really nice feature from Spring Data JPA. So the specification is also something. So let's start with specification. So the specification is something, or is a technology that we can use also to filter the data. So we can create some specifications, apply them directly, and this will also filter the data. All right. So let's go back to our game domain, or the part that we want to work on. So in here we have our game repository. All right, so here, in order to enable the JPA specification, we need to extend another interface, because by default the JPA specification is not enabled, or is not ready to use unless we enable it. And how to enable it? We need also, okay, so I think IntelliJ is reading my voice, or is listening to my voice, or reading my mind. But anyways, so here we have a JPA specification executor. So it's almost the same like QueryByExample executor. But for this one, we will create some specifications. And I will explain what specification is and how we can create a specification. All right. So for the first thing, all we need to do is to extend this JPA specification executor. And here, among this one, we have few methods. So for example, find one, and we need to pass a specification. So the specification is an interface, and it contains some methods, like where, we have the and, we have the or methods, we have to predicate, all of, and so forth. All right. So and I will show you the examples right away. So this is the first thing. The second thing I want to create is to create a class. This is just to organize the code, by the way. So you can make it, or you can use the methods that we will create in this class directly in your service without the need to create a class. But just to organize things, I just want to create a new class. So this one, I will call it game specifications. All right. So this game specifications is just a simple class, and that will contain some static, or public static methods. So here I will do public static specification. All right. So this is an auto completion, which is super nice. Okay, that's also nice. I think the version, or the last version of IntelliJ is really awesome, because this is what I had in mind to write. Well, it was not by game, but it was the same. All right. Anyways, what do we have in here? So here, I just create a public static method. This will return a specification. So as you saw in here, when I want to do find one, find all, or any of the find methods, I need to pass an object of type specification. All right. And this is what I created in here. So the specification, it takes the root, so it's a root of game, the criteria query, and the query and the criteria builder. So for the people, or if you already watched the video that I published, I think some time ago, about how to use criteria query to build your queries. So this is an advanced version, or an enhanced version of writing criteria queries. All right. So here, all I need to do, let's, for example, let's say by game title instead of game ID, and here let's rename this one to game title. And in here, all I need to do, maybe let me break the line so you can see it all. All right, so here what I want to do. So I have my root, I have the query, and I have the criteria builder. So the root is the game object itself. So the query is the query that I'm building, and the criteria builder is the criteria that I want to add. All right. So in my case in here, I want to filter, or I want to add a filter to fetch, or to find the list of games by title. And maybe let's try to rebuild what we already built in here in the game service. let me open my game service again, and maybe let's try to rebuild one of these examples, or like these examples. So here we had the first one to be like I want to filter, or like I want to find one game by title, or like by this object. All right. So now all I need to do, so here as you can see the criteria builder, and I have this equal method. So here I have equal exists between greater or equal, conjunction, and so on and so forth. So here we have much more methods comparing to the query by example executor. So let's say for example here I want to use I want to filter exactly, or like I want to find a game by the title. All right, and here the root.get. So this .get method, it will try to get the title, sorry, not the title, but the attribute that is called title in here. So here I need to pass title in this one. So like root.get should be the attribute name. All right, and then the parameter that I want to use to filter. All right, so I will create another public static specification of type game, and here let's say for example by supported platforms. All right, or like just a platform, or here I can just pass a supported platforms and the platform. So here all I need to do is to return the following here. So it's a lambda expression. So we have the root, the query, and the criteria builder. And here all I need to do is to do my criteria builder. And here I have, for example, contains, or I think it includes, or sorry, it's in. But for example, here I can pass a list of platforms. All right. For example, assuming that I want to pass a list of platforms. So here, or let's make it simple for the first time. And here, let's say, for example, I want also like to filter my games by supported platform. So like I want to find all the games that the platform equals something. All right. So now I have two specifications, or I have two filters. All right, so I have two filters. Let's see how I can use these filters, or how I can apply these filters to my method. All right, so now in order to apply these filters, all I need to do is to build my criteria, or like to build my specification. All right, so like here, just put in mind this specification is just a filter, is just a part of filtering, and the way I use them, it depends, like it will decide the result. So this means what? I will just show you in a few moments. Again, let's use public void specification example, and here. So, and here what I want to do, here I will create a specification of type game. All right, so I will call it specification, or just a spec, just as a shorter name. And here I will use specification dot where, and I will pass a null as a parameter in the beginning. All right, so like it will be a null. So here, for example, I want my specification equals, so like here I just need to append it. So here I want to filter all the games by title and supported platform. All right, so here all I need to do, it will be and here I have my game specification dot by game title, and let's assume here, for example, Witcher. All right, so then I have spec equals spec, and now my game specification dot by game game title we already used, and here supported platforms, and let's say for example PC for this time. All right, so here of course here we have I separated them into two lines, but I can do it in one line. All right, so I can do it in this way. All right, so now this will result in my specification. Now I will have my result, it will be a list of games, and then game repository dot find all. And here among these find all methods, I have a method that accepts a specification. All right, so like it accepts a specification, which is like a specification of type game. So this is the specification that I just built. All right, so now why I separated this into two lines. Here I will create a private void build specification. Build specification, and I will have a string title and a supported platform. So assume that here I'm not sure if I have the title and the supported platform, or I have the title or the supported platform, and so on and so forth. So for example, if the title is null, I want to filter by title. If the platform is not null, I want also to filter by the supported platform. So let me show you how we will do that. So this will return a specification of type game. And now in the same way, I will just copy or like move this code here, and then just return spec. So now what I will do, so here, if my string utils, for example, dot is empty, or like has length, I guess the method, yeah. If I have the title, all right, I want to use this part. I want to use this one. And now if, for example, my supported platform is not null, I want also to use, or like I want also to filter by supported platform. So here it will be spec equals spec and then dot end. All right, so build specification, let's call this one with and operator. And now all I need to do, I will create again my specification of type game. I will call it spec equals build specification. And here, let's say, for example, Witcher. Sorry, I need to change this one to title and this one to supported platforms, or like to platform, sorry. And here, let's say Witcher, and then supported platform PC. All right, so like this is one way of writing, or like this is a way, or like the best way to write this. So here, just create a method to build your specification, and the specification is just a list or like a set of filters. All right, so like this is what specification is. So it's a set of filters. So here I can filter, or like this is my first filter, this is my second filter, and so on and so forth. And how I want to use these filters is up to us later on. So like here in this case, we just used and operator. And now, for example, I can specification example 1. So let's call this one maybe specification example 1. And here, let's call it example 2. All right. So here, let's say with or operator. We do not have this method yet. Let's duplicate this one. So we can even refactor this one to pass the operator and then using the and or and so on and so forth, but to make things simple. So here, like using the or operator, and here instead of the and, I want to use the or. All right. So using the or, so here I want to have and title, for example, assuming that the title should not be null, and then, for example, title or platform. All right. So like I want to filter by title or platform. All right, so this is how specification works. So specification, like generally speaking, just defining a set or a list of specifications, and each specification would be considered as a separate filter. All right, so like you can also like create more complex specifications in here. So for example, let's say filter by owner ID or something like that, and here in this root, or like in this part in here, you just get, for example, let's say by category name. All right, so let's add something like that. So here I will create a public static specification of type game by cat name, for example. So in here we have category So in here we have our object category. So I want to get my category and then dot get and then name. Let me just make sure what we called this one. Yeah, we have it. It's called name. And then get name to be equal my category name. So like this is something, as you can see here, I can access the object which is inside the object, inside my object. So like here I have my game. So like I have my game object, and inside the game object I have a category. So like from this root, which is a root of type game, as you can see here, so I can access the category field, and I know that my category field is also an object, so I can access its attributes. All right. So now so this one will become an object of type category, and then from that one I can access the name. So then now I can filter by category name, and then I can use that specification in my service class. So just coming back to what I was explaining just before. So specification is a set or a list of filters, and then it's up to us how we want to combine these filters, like whether using and operators, and operator, or like or operator. So just like we did in here. So here, for example, we can use an and then or, and then we can combine so many of them, like with an and or, and so forth. So here we can also have grouping. So like we can group specifications. We can do, for example, like where title equals something and platform equals something, or title is null, and so on and so forth. So like this limitation that we spoke about here, like the specification of the query by example executor is not present in here. So like with this one, we do not have any limitations. Like all we need to do is just to move on and write the code and like prepare our filters and like this one, we call them also predicates. We just prepare our predicates in order to filter our data. All right. So this was about and yeah, something else. So as I mentioned in the beginning, so like I just created this class just to organize the code, nothing else. All right. So just to organize the code. So like I could, for example, just take this code right here and put it directly inside my service, but this will make my my class much longer and like with a lot of code, and it's better to organize the code into classes. All right, so now we can move. Just drop a comment if everything is fine, or like if you have any questions, I can also answer them. Now we can move also to another topic, which is very important, which is projections. So like now, like today we saw the paging and sorting, we saw the query by example. Also, like we saw the specifications, and now the last thing that I want to show you today is projections. How to create projections, or like what projections are. All right. So here I have a game. I have my game object, and then I can write queries to fetch so many types of data, or like many versions of games, or like of my game data. This means what? What do I mean exactly by many versions? So let me explain it in here. So for the game, we have fields. We have like few fields. We don't care like what do we have exactly. We have an ID, we have a title, we have supported platforms, we have something else, and also like we have the relationships with the other tables, like category, like comments, like all the other relationships. So now what I want to do, I want like, so this will be the example one. So this will be example one, like the type or like the example of data that I want to retrieve. So for the example one, I want to fetch the ID and the title. And for example, let's say supported platforms. Supported platforms. I want to have an object that contains all these three fields. I want to have another object. So let's say example 2. I want to have only the title, and I want to have the category name. All right, so I want to have category name. And then let's say, for example, I want to have an example 3, and I guess only 2 examples. This will make you understand what I want to do. So we will come back to this one if you do not get the idea. So I will explain it more in details. So here in a classic way, what would we do? So here we will create a class. We can call it, for example, game representation 1. And this class will contain ID attribute, title, and supported platforms. Then we will create another class. Let's call it, so here it will be another Java class, or record, like the same. And this one will be, for example, like game representation 2, and it will have, or like it will contain title and category name. And again, of course, like we need to get the data, we need to do the mapping, like we need to transfer, like to loop over the list, do the transformation, and then return it back, or like send it back to the client. But Spring Data GPA comes with a solution, with a nice solution that will help us so much to avoid like a lot of code. So just coming back to here. So in the game service, maybe let me commit this one. Specifications. All right, so let me just push this one to have like separate commits, so you can see the changes. So here, like usually what we would do, so like we would create a class. Let's call it, for example, game representation, or like game response 1. Or like game representation 1 with ID, title, and then platform, for example, or like platforms. And then second step is call the game repository and fetch, oops, I don't know what's going on with all these typos. And fetch all the games. Let's assume it's paged, because we mentioned that this is really important and we should not forget it. And then map the data, map the result. And how to map the result, like loop over the result from the DB, from the database, do the mapping, and then collect, and then like return the result. All right, so, and then of course like just finally returning the final result. But here, like we need to create a class, we need to fetch everything, and then do the mapping. So like we need to first like create a class. So like this, there is no escape from that. We need always to create an object that will represent, or like that will contain the data that we want to return. And then we need to loop over the elements, do the mapping. So like we need to create a method that will do the transformation, collect, and then return the result, because like the mapping, because the method should return an object of type game representation 1. So like if we want to have another class or like another representation, we need another mapping methods, and so forth. But we have something easier, or like Spring Data GPA comes with a better result, with a better solution for that. So the solution is I will create an interface, and I will call it game representation 1, for example. Like this will be the first representation. And in here, all I need to do is I will have, for example, a string get title, or maybe like get ID, as we mentioned for the first example. And then a string get title, and let's say string, for example, supported platforms, or like, okay, so let's stick only with these two. So now I will create a method that will return a list of game representation 1. get games with representation 1, for example. And here, like what I would do, so like I would create, so like here, assuming that this is a class, I will fetch everything, do the mapping, and return the result. But within Spring Data JPA, so here if I go to my game repository, all I need to do is to have a list of game representation 1. Let's call it find all games. We don't care about the filtering. So in here we have one condition. So you see here we have a get ID and a get title. So the most important part is to have, so like the query annotation is not necessary, or like is not mandatory, but this is what we need. So we need to do select g.id and then g.title from game G. I don't know why. All right, so game.id and game.title sorry, from game G, and imagine here, for example, we have a where close or whatever. So this is the most important thing. So like the field name, or like the field output name, should match this get method. So like we just ignore the get and we transform this one to a lowercase. So this is how it works. So now this is what I mean exactly. So like maybe I can make it clear. So here I will call this one game title. All right, so like get game title. So here we have a title in here, but I want to return a game representation that I want Spring Data JPA to map these fields directly into these two methods, or like these two values, or like attributes. It will be able to map the ID, but it will not be able to map the title, because the field in here is called game title. So now what I can do, I can use as game title. Right, so as this is an alias. All right, we delete this one, and here, for example, if I want, for example, to call it game ID like this, all I need to do is to call it as game ID. All right, so the names should match the method names in here. So like the results, or like the query names in here, or like the query aliases in here, they should definitely match these ones in here, without the get, of course, and the first letter should be lowercase. So in this way, all I need to do in here, just return game repository dot find all games, and that's it. So now it's just one line. All right, so like I don't need to get all the games. Okay, I need to create this one, but I don't need to get all the games. I don't need to loop over, mapping, collecting, and then returning the result. All I need to do is just to return the list of games. Now, assuming that I want to have a second representation. So now I want to have game representation 2. All right, so this game representation 2, I want to have a string game title, for example, and I want to have a string category name. So get category name. All right, so now again in the game repository, I just need to do the same, and then game representation 2, find all games 2, I will just call it 2, and here I will just copy paste the query just to make it easier and faster. So here I don't need the game ID, so I will just remove it. Now I need my game title, and it should be game title as in here, and now I want my category name. All right, so I'll just copy this one to avoid issues. So here I can do g.category dot name as category name, And that's it. Spring Data GPA will be able to automatically map these two fields, or like these two columns, into these two get methods in here, or like these two attributes in here. So like this will allow us to avoid so much extra code. All right, all I need to do is to create an interface with some get method. Sorry, here it should be get game title with get methods, and with this get methods I just need to define the attribute names, and this will automatically be mapped to the result. So I don't need to do that. All right. So I don't need to do extra work, but of course we have some limitations with when using the game representation, or like the projections. And one of the limitations, so I will explain it when we come to the Redis part, like when we come to implementing the Redis part. So like one of the issues is serialization. All right, so like when we want to serialize an object, for example, for Redis. So like this is an issue that I faced when I was working with Redis and I wanted to use projections. All right, so now let me also commit and push this code, and here projections. And now it's time for you to ask your questions, and I will be waiting for your questions. If you have questions, just go ahead and post them in the chat. If you do not, just let me know that you do not have questions, and we can end today's session. I will be waiting for your input. All right, so we have one first question. I have a question unrelated to today's topic. Is creating tests part of the bootcamp? Okay, if you mean so if you mean tests, like if you are talking about unit tests and integration tests and E2E tests, so the answer is yes. But if your question is different, please try to ask me again. So we'll use projections with Redis. So I will explain what I meant when we come to the Redis part. I will explain to you everything, or like what was the issue. So like we cannot use projections with Redis. It's not the other way around. So like we will not use it. But of course, like we will use projections, but not for the objects, or like not for the data that we want to cache it on Redis level. The projections look a bit like GraphQL. Honestly, I don't really think so, but yeah, assuming yes, like, but for my case, or like from my side, I don't think so. Do you have any other questions? Just go ahead and ask your questions. Okay, so yeah, I already answered your question. So like of course, like we will have unit tests, we will have end-to-end tests, we will also like see test containers, and like for testing we will see an interesting topic, like it will be an interesting session. We will go through so many things in unit testing. From my experience, I didn't see so many people using that, like when it comes to JUnit and Java. All right, guys, so like if you do not have further questions, please let me know in the comments, and I wish you a nice evening or like a good night, or like also like thank you so much for being here today. It was as always a pleasure working and being with you. So yeah, if you do not have any further questions, I would say thank you so much and see you in the next one. Right, so for Taito, when will be next session? So like as I mentioned, as I always mention, like the sessions are always Sunday at 8 o'clock in the evening, like EU time, or like European time. So like today's session, exactly like it will be always every Sunday like today. All right, so thank you so much. I hope you enjoyed today's session. I hope everything was clear, and I hope like you get some new information, some new topics. Thank you so much, and see you in the next one.